In this next video, we're going to be finishing up example 2, where we're looking at two horizontal transformations, and we're going to be looking at the tangent function and then also making a summary down at the bottom. So for this particular one, we have, again, two inside changes, and so those are both going to be horizontal. That changes the x values. We do need to factor this, so this will be tangent of, so the 1/2 is coming out here, and then what do I need here? Well, 1/2 times this has to give me 1/2 x, so I need an x. And 1/2 times whatever I put here has to give me pi over 2, so that's just going to be a pi. And you can kind of double check that for yourself. If you distribute that out, you'll see that you'll get what we started with. All right, so that means that the scale factor for this one is going to be 2. Remember, it's always, when they're inside, it's always sort of opposite of what you think, and so the scale factor is the reciprocal, which is 2. So we're first going to multiply by 2, and then we have the minus pi, and so that means that we're going to add pi. So now if we go through this, so times 2, and again, I'm going to let you do most of the arithmetic, but I'm going to do 2 times negative pi over 2, so the 2's cancel, so I just am left with negative pi. So that's going to be negative pi. 2 times negative pi over 4 is negative pi over 2. 0, pi over 2, and pi. Then we're going to add pi. So negative pi plus pi, of course, is 0. Negative pi over 2 plus pi. Again, you need a common denominator, so that would be 2 pi over 2. So that's going to give you pi over 2. And I will let you do the rest of the arithmetic. 0 plus pi is pi. Pi over 2 plus pi is 3 pi over 2. And then pi plus pi is 2 pi. So that's going to give us our new x values. So when I draw this graph, notice, by the way, that the vertical asymptotes have switched. The vertical asymptotes are always at the ends, so usually they're at negative pi over 2 and pi over 2 in the parent function, but they're going to be at 0 and pi over 2 for this one. So I'm going to label all of these x values. So I have 0, pi over 2, pi, 3 pi over 2, 2 pi. Those are my new x values. And I haven't done anything vertical, so those these key points that are back here that have a y value of 1 and negative 1, those are going to stay. So when I sketch this graph then, my vertical asymptotes are at the end, so I'm following the form here for the parent function. And then again, if you want to kind of box it in, we can say that this is the middle, this is the top, this is the bottom, so this is still our principal axis, and yeah, and then the left and the rights are here. And that corresponds to sort of this box right here on this graph. So we can see that right in the middle of the box, which is right here, we have a point. And then at the quarter point, it's down here at this lower value. And then at the 3/4 point, it's up here at this upper value. And then just try to make it curved when you graph it. And again, you can check that on your graphing calculator. So the period of this one, then if we look at this total distance that it takes to go across one period, is a total 2 pi. If I do 2 pi minus 0, that's 2 pi. So the period of this one is 2 pi. And then the phase shift we get from right up here, and this is going to be right pi. Now I want to point out that on the sine and the cosine, this value that was right here, the minus 3 or the 3, or the negative pi over 2 corresponded to the start of this. But it's not the same on the tangent. It's going to correspond to the middle. And why? Because that's where the 0 is. And that's the one that's not affected by multiplication. And then when I add pi, it gives me pi. So we can see the translation for this one. If I, again, just go back to the origin and say, where did the origin end up? The origin ended up here at pi. And so we can kind of see the going right pi. Now, let's talk about a general formula for the period. So if we go back to sine and cosine, what I want you to notice is, let me pick a different color here. What I want you to notice is that the scale factor for A was 1/2. And remember that the original period is 2 pi. And so if I take that 2 pi and multiply it by the scale factor, so in other words, everything everything on the sine function is getting shrunk. It's getting shrunk down, I guess, by the scale factor of 1/2, including the period. So if I take the original period of the sine graph, multiply it by 1/2, I get pi. And that's what we see here. The period is pi. On this one, the scale factor is 1/pi. So if I take the original period of 2 pi and multiply it by the scale factor of 1/pi, I end up with 2. And we saw that that was the period of this function. So if we go down here to summarize, when we have a sine or a cosine graph, because the original period of both of those is 2 pi, then the new period is just going to be the scale factor, which is b, or I'm sorry, the scale factor, which is 1/b. Let's write it here. Times 2 pi. So scale factor times the original one. Now, what we usually do is put an absolute value in here, just because it is possible for b to be less than 0. We're not actually going to do any graphs where b is less than 0, but we put it in there anyway. So then when I multiply that, I get 2 pi divided by the absolute value of b. So this is going to be 2 pi divided by the absolute value of b. Okay. Now for tangent, that one's a little bit different, because remember that the original period of tangent is pi. If we go from pi/2 to negative pi/2, that's a total of pi. So I can again do the scale factor. So notice on this one, the scale factor was 2. And so if I take the scale factor of 2 times the original period of pi, I get 2 pi, and that is the period of this one. So again, on this one, for tangent, it's going to be the scale factor, which is always 1 over the absolute value of b, times the original period, which is pi, and so we end up with pi over absolute value of b. So this is pi divided by absolute value of b. And that's the formula for the new period of a tangent function.